Hi everyone, me again. I'm back with more exponential growth and decay. These are the sort of word problems examples that we're going to work through that you're going to see in this section. And so you should have this sheet in front of you, okay, so you can just kind of follow along with me. And I want you to keep in mind that all of these are going to have the format y equals ab to the power of x. Okay, so looking at example 1, a rare coin is worth $6,600 in 2010. Experts expect, that is a hard thing to say, its value to increase at a rate of 2.3% per year. Okay, so write an equation to model the value of the coin after X years. That's where this comes in, okay? So we know we're going to have a Y, we know we're going to have an X, we really just need to fill in A and B. Well, A is the initial value of the coin, so we're going to say that this is our A value. We're starting with a value of 6,600. The year 2010 is going to be important in a minute, but we don't need it right now. And then we're increasing its value at 2.3% per year. Now you have to be careful here because you don't just want to multiply by the 2.3%. That's actually going to make it get smaller. If you take 2% of something, that's going to be smaller than what you started with, right? So remember that to make things grow with percentages, I actually have to take that 2.3% and add it to 100%. Okay, so 100% of what I started with plus an additional 2.3% gives me 102.3%. And then I'm going to move the decimal on that. And so my B value is going to be 1.023. That's a really important thing to do in this section. That's going to come up quite a bit, the adding and subtracting from 100%. And I will tell you that if you forget to do it, your answer is going to come out ridiculous. Okay, so if you get an answer that is ridiculous, that's the very first thing I would check. So my equation for this is going to look like this. Y equals 6,600 times my B value of 1.023 to the power of x. That's just my general equation. And then x is going to represent, like it says up here, x is the number of years, but the number of years from when our function started, and our function started in the year 2010. So in this case, the number of years really represents the years since 2010. Okay, so what would the value of the coin be in 2016? Well, if we started in 2010, I'm looking for 6 years later, so we're going to let our x equal 6. So what I'm really typing in here is 6,600 times 1.023 to the power of 6 and getting an answer. Okay? And so that would look like this. 6,600, oops, one more zero, times 1.023 to the power of 6. And there's my value, and you have to think about what this represents. This is money, right? This is a value. So I'm going to go ahead and round it like money. I would put my answer down as $7,564, and I would probably round that to 81 cents. Okay, so there's the value. Oh, that's supposed to go up here. Sorry about that. 7,564.81. Ignore this. Okay. Okay, now this next question, in what year would the value of the coin surpass $10,000? So if this is talking about the value of the coin, this 10,000 would really go in place of y, right? That's really talking about the value going here. Well, I don't have a way to solve for an x up in the exponent, at least not yet. Okay, we're going to learn a way later in this chapter, but for now, really I can just do this kind of by estimation, okay? And so what I'm going to do is I'm going to type this original equation into my graph part of my calculator. Okay, so I'm going to go to y equals, I'm going to clear all this junk out, and I'm going to type in 6,600, I put that on y3, but it doesn't matter, times 1.023 to the power of x. I'm going back to x because now I'm looking for the more general form. I'm not looking for this specific case. So don't put a 6 in there. I want the x. And then I can graph it and look at it, but the picture is not really what I'm concerned about. What I'm going to look at is the table. And this shows me, based on the number of years, so remember x represents your number of years, what the value of the coin would be in any year. And so, like, for example, if I look at the number 6, I'll see that answer that we just found a second ago, that 7564. Okay, but I'm looking for when do we first cross over $10,000. So I'm just going to scroll and scroll, getting close there. There we go. So in year 19 years, I'm going to go over $10,000. Okay, so we know it's X equals 19 years. And then because it asks us in what year, that doesn't really tell us in what year that will be, but that's 19 years from 2010. So that would be the year 2029. Okay, so I really just added the 19 to the 2010. Okay, so in the year 2029, the value of my coin would be over $10,000. Okay? Okay, I think I can get one more in. Example 2. A used car's trade-in value depreciates. Depreciates means that the value goes down by 20% per year. Okay? And then we're purchasing a car today for $12,000. So the value of the car, the initial value is $12,000. We're going to call that A. I would say Y equals 12,000. And then for my B value, remember what we really care about is what percentage are we keeping. So if we're losing 20% per year, I don't want to multiply by 20% because that'll tell me what I'm losing. I want to do 100 minus 20%, just like I did up above, except I'm subtracting because I'm depreciating. So I'm keeping 80%. And so this would be 0.80 that goes in here. And then it's every single year, so this would be to the power of X. There's my model. And then the year 2020, well, we have to think about what year did this function start in. It says I'm purchasing a car today, so I can assume that's 2016. In 2020, that's 4 years. So I want to know how much, what would my value be if I put a 4 in for X? I would do 12,000 times 0.80 to the power of 4. Okay, so 12,000 times 0.8 to the power of 4. And I really want you to think about your answers, okay? Is this a reasonable answer? I mean, you're losing 20% every year, so it's going to go down pretty quickly. But if you got like a tiny decimal, like pennies, okay, hopefully your $12,000 car is worth more than pennies 4 years from now. And also, if you got a number that was bigger than what you started with, you might know that you made a mistake there somewhere because you're supposed to be depreciating. So this is a value of $4,915.20. Okay, I'm going to have to do a second video to cover examples 3 and 4 because you pesky 4th hour kids are standing outside my door right now. So another video will fire up in just a minute.